Hello everybody, welcome to our fourth and final video for Quiz 8. This is for problem 1D, our final series whose convergence or divergence we're meant to detect. And here, well, let's see, we've got a double factorial, craziness, a normal factorial and an exponential. And I'm generally partial to using for factorials, either the root test or the ratio test. I love the root test, to be honest. But with double factorials, I feel more comfortable jumping in with the ratio test. In case you don't remember, what does a double factorial mean? So double factorial, basically you're going to be counting down by 2. So this is an odd number, 2n minus 1. And so that tells us we're going to start from 1 and multiply every other number. All right, so we're counting by 2 and multiplying until we get up to 2n minus 1. If this had been a 2n, incidentally, we wouldn't start with 1, we would instead start with 2, right? And really, you should think of it as starting from 2n and then counting down, right? That way you know you're always going to end up on even numbers. So there we go. So that's what this double factorial business means. So again, I'd like to use the ratio test. Nice thing here, I'm not going to have to worry about absolute values. Everything is positive. So when I go to use the ratio test, I can take the limit as n goes to infinity, and I don't have to write down absolute values here. Now what do I need? I need first the n plus first term in this sequence. So I'm going to replace n by n plus 1. So when I do that, I'll get 2n plus 1 minus 1 over 3 to the n plus 1 times n plus 1 factorial. And then I need to divide by the nth term, which of course we're looking at, or if you like, multiply by the reciprocal. So 3 to the n times n factorial over, we forgot the double factorial on top, didn't we? Over 2n minus 1 double factorial. Okay, well, we can do some cleanup here. So first thing, this 2n plus 1 minus 1, okay, that's just going to be the same as 2n plus 2 minus 1, which is 2n plus 1. So I have 2n plus 1 double factorial. And let me just combine that here with the 2n minus 1 double factorial. Okay, what else do we have? Well, I have a 3 to the n over 3 to the n plus 1, and that I'm going to be able to cancel. I'll just get 1 over 3. And then I have n factorial over n plus 1 factorial. So remember that n plus 1 factorial, that means you're multiplying everything up to n plus 1, starting from 1. Well, that's the same thing as multiplying everything up to n, and then multiplying one more time by n plus 1. So if n plus 1 factorial is n plus 1 times n factorial, the n factorials will cancel, and I'm just left with 1 over n plus 1. Okay, the only thing that's a little bit wonky still here is this double factorial, but what does that mean? Well, notice 2n plus 1 and 2n minus 1 differ by 2. So 2n plus 1 double factorial. That's just the next in the sequence, right, of factorials, just like, or of double factorials, just like n plus 1 factorial was the next in the sequence after n factorial. So this is equal to what you'd get if you did 2n minus 1 double factorial. That would take you all the way up to 2n minus 1. And then the next term, right, you'd multiply by 2n plus 1. So I'm going to be able to cancel the 2n minus 1 double factorials. And I'm just going to be left with a 2n plus 1. So I'll have 2n plus 1 over, and it looks like 3. Let's say 3n plus 3. And we've seen this in the other videos. When we get to this point, we know we just look at the highest degree terms, right, for n, and when they're the same, the limit will be the ratio of the coefficients, okay? If we want to write that down rigorously, we can divide an n, and I'll get 2 plus 1 over n, and then I'll divide an n on the bottom, and I'll get 3 plus 3 over n. The n's will cancel, and so I'll have 2 plus 1 over n over 3 plus 3 over n, The 1 over n goes to 0 in the numerator. The 3 over n goes to 0 in the denominator. And so I'm left with 2 plus 0 over 3 plus 0, which is 2/3 as my limit. Okay, cool. Does that mean the series converges to 2/3? No way, not even in the slightest, right? We're using the ratio test. The ratio test says we compute this limit, and if the ratio we get is less than 1, then the original series converges. We have no idea what it's converging to. Okay, so by the ratio test, the original series, where we have 2n minus 1 double factorial over 3 to the n times n factorial, converges. Okay, if this had been greater than 1, we would have known that the series diverges. And if it was equal to 1, we would have cried a little because the test would have just failed. All right, hope I didn't scare you with the double factorial. All right, it's not much worse, but we're going to need it later on in this course when we start finding solutions to differential equations using power series. This double factorial will be very, very handy. All right, we will see you next time, everybody.